Okay, so rational root theorem, I guess if we were to use a footballing parlance, it's a one percenter. It's just one of those little ones that may pop up. Haven't seen it pop up yet on an exam, but who knows? So what it's actually telling us, that when we do our division up until this point in time, there's always one integer solution that we can then divide into our polynomial. Well, what if there's not? What if there's not an integer solution? How are you meant to find it? And that's what our rational root theorem tells us, all right? So if, for a polynomial, if p of negative alpha on beta is equal to 0, so that's my solution. So let's put that in context. Alpha x plus beta equal to 0, and then alpha x is equal to minus beta, x is equal to negative b on alpha, yeah? So if p of negative b on alpha is equal to 0, it means that alpha x plus b is my factor. All right. Now, where are the alpha and the beta come from? Alpha actually divides the constant term, so it's a factor of the constant term. Beta is a factor of the x cubed coefficient. So that's the combinations that we could be looking at. All right. So let's have a look at this one. The x cubed coefficient is 3, which means beta could be plus or minus 3 or plus or minus 1. All right. The constant is negative 5, which means alpha could be plus or minus 1 or plus or minus 5, which means my solution of alpha on beta could be, well, alpha could be 1 or 5 and beta could be 1 or 3. Now, up until now, we've only ever considered, I guess, our denominator as being the 1 factor. So we'd have guessed plus or minus 1 or plus or minus 5 as solutions. And in this case, we discovered that they're not. So then the next step is to consider, well, what are the other factors of the x cubed coefficient? And in this case, they're 1 and 3. So reasonable guesses, and this is the only way that we've been able to come up with to be a reasonable multiple choice sort of scenario, is any of these numbers would be reasonable guesses as to what a possible solution to p of x equal to 0 could be. So the factors of the top are 1, factors at the bottom are 3. Okay, obviously the other possible solutions would be 1 on 1, p of negative 1 on 1, p of 5 on 1, p of negative 5 on 1. There are other possible factors that you could guess. All right. So I didn't worry about using manually. I did pop them into the calculator and soon discovered that p of negative 5 on 3 was equal to 0. All right. So if negative 5 on 3 is a solution, it means 3x plus 5 is a factor. Yeah. So don't forget that if I was going to try and solve 3x plus 5 equal to 0, it means that x would be equal to negative 5 on 3, which is what I'm looking for. So 3x plus 5 is a factor. Divide that into my polynomial. I'll end up with x squared plus x minus 1 as a solution. As a factor, as a quadratic factor. If I actually solve that equal to 0, I don't get rational solutions. I get 1 plus or minus root 5 on 2, and you would never guess that. So the only things you can guess were the negative 5 on 3 or these irrational numbers. Okay, and that's where my rational root theorem comes from, and that's what it is. It's just telling you that it's not just an integer value that might be the solution to your equation. All right, okay.